A rate is a type of ratio. And when we look at weather forecasts, it is helpful to know how ratios can help us make sense of what we can expect from the weather that day, as well as rates. They show us different things. Often a rate is defined as a ratio comparing or associating quantities that are measured in different units. Examples of this are miles per hour, miles per gallon, temperature changes per hour, sea level changes, right? Tidal changes over a day because high tides and low tides, locations of the moon, or phases of the moon. I love that. A percentage of moon illuminated per to the day of the month, because we know that the moon phases through a month cycle. Okay. All right. Okay. Looking at the rates in this weather forecast, we're trying to look past the moment. We're trying to look past what's happening at 6 o'clock, what's happening at 9 o'clock, what's happening at 12 o'clock. To plan our day, we might also want to look at how the temperature is behaving, not just what is it. What is it? It's not just a picture. I mean, these ratios in this ratio table, actually, forgive me, this is a table. This is not a ratio table because these are not equivalent ratios. These are not equivalent ratios. So this is not a ratio table. It is a table of values that may or may not have an association. Okay. Powerful. I just said that. We don't know if they have an association overall. We know that at a given time and a given temperature, those are associated, but we don't know if there's a pattern overall. And that's what rates are going to help us with. So I have here sort of a note to help you all see what's going to happen. If you look here, the 34 and the 9 are associated with each other. Just we're pulling in two ratios to think of a rate of change. So when I look at 34 degrees at 9 o'clock and 30 degrees at 6 o'clock, I want to make sure that I respect that order, right? Ratios are really dependent on order. Order matters in terms of not like first and second, like this is better or worse, or a hierarchy, but just like if I say temp comes first, then I have to list the temperature first. If I say hours comes second, I have to list the hours second. If I'm putting 9 o'clock's temperature first, I need to put the 9 o'clock hour first. It all just has to be like ordered. It can't be mixed matched. And then I can simplify. Okay, so just looking at from here, it's almost the exact same thing, just we changed it so that our subtraction would end up with a positive number. But like from 30 degrees to 34 degrees, 4 degrees warmer, from 6 to 9 o'clock, 3 hours later. So it makes sense that the temperature raises 4 degrees every 3 hours. But what is that as a unit rate? There's many ways we can figure out unit rates. Some may choose to write something called a proportion. This is called a proportion. Okay, so let's go through a couple methods, strategies, structures you can use to start thinking about equivalent fractions, equivalent ratios, proportions, unit rates, all of this. It's all associated, but they're all little, we have different words for different things. Okay, so this is using a proportion. What do I have to do to 3 using multiplication and division? Because ratios are a multiplicative structure to get to 1. It's not subtract 2. We're not using an additive structure. Ratios, rates, these are multiplicative and divisibility, but multiplicative and division go together. Multiplicative relationships and structures. So you're relying heavily on multiplication and division. Questions with that? Leave in a comment below. Send me an email. Okay, then if I want to use a proportion, then I'm thinking about the fact that I want to multiply or multiply by a third or divide by 3, right? So I'm going to just say divided by 3 equals 1. And then to do the same thing to the numerator. You have a prediction of what the mystery X is going to be, the box. So 4 divided by 3 is 4/3. 1 1/3. Isn't that funny? That's how I would leave it. I prefer fractions over repeating or really long decimal expansions. You clearly could write 1.33333. I simply prefer 1 1/3. It's more precise in my opinion. So this tells me that every hour the temperature rises about 1 1/3 degrees Fahrenheit. There are so many other ways you could have found that value, that solution, the unit rate of temperature changing over the time. So let's try it again, but we'll go from 6 a.m. to 6 p.m. Okay? So pause the video now if you would like to try this on your own. Okay, but we're gonna see if the unit rate from 6 to 9 a.m. is the same as from 6 to 6 p.m. What do you predict? Do you think that the temperature change is the same from 3 hours in the day to 12 hours in the day, or is it going to look a little different? Okay, so let's check that out. We want to compare, so we still need 30 degrees from 6 a.m., but we just need that last value. So it's 37 degrees at 6 p.m. Okay, so instead of 34, we're going to 37, and instead of 9, we go to 18 because 6 p.m. is noon, right? Plus 6. Why can't I click? Okay. I lost internet.